Ahoy! Today we'll be working on calc problems, arg. Right here is our question. A particle moves on the x-axis so that its velocity at any time t is greater than or equal to 0. Is given by v of t equals 12t to the second minus 36t plus 15, arg. At t equals 1, the particle be at its origin. There be no treasure here, only a problem. Let's just get it over with. Here we have to find the position of x of t of the particle at any time t is greater than or equal to 0. So here we have x of t equals the integral of u dt equals 4t cubed minus 18t squared plus 15t plus c. And then we go down a line to find that x of 1 equals 0, which is the equivalent of 4 minus 18 plus 15 plus c. Therefore, we find that c is equal to negative 1. Now we have to find all values of t for which the particle is at rest. Particle is at rest when v of t equals 0, and v of t equals 3 times 4t squared minus 12t plus 5 is equal to 3 times 2t minus 1 times 2t minus 5. And then we come down to the bottom and find that the answer is v of t equals 0 when t is equal to 1/2 or 5/2. Arrgh! Now we have to find the maximum velocity of the particle for 0 is less than or equal to t and greater than or equal to 2. v prime of t equals 3 times 8t minus 12, and we find that that converts to v prime of t equals 0. When t equals 3/2, and t is greater than 0 and less than 2. That's about all I've got for that one. Anyways, v of 3/2 is absolutely minimized at v of 0 or v of 2, and that's an absolute max, probably. Then we find that v of 0 equals 15, and that v of 2 equals 3 times 16 minus 24 plus 5, and that's equivalent to negative 9. So in conclusion, v has an absolute maximum of 15 at t equals 0. Now for the last step of this accursed problem, we need to find the distance traveled by the particle from t equals 0 to t equals 2. Here we have a chart. On this chart, you might find such numbers as 0, 1/2, and 2, and their corresponding values on the x of t graph. What we've done is we've calculated the distances betwixt the twos of them, and then we added them together to get a total distance of 17. Arrgh. Arrgh, this problem be a bit of a tough one. So for part A, we have shiver me timbers. We have to find the velocity of the particle at any time t is greater than or equal to 0. So here we have x of t equaling t minus 1 cubed times 2t minus 3, where t is greater than or equal to 0. And then we have v of t, where v is equal to velocity, equals t minus 1 cubed times 2 plus 3 of t minus 1 squared times 2t minus 3. We digress into the next line where it says t minus 1 squared times 2t minus 1 plus 3 in parentheses 2t minus 3 in bracket parentheses and what have you. Down to the next line you see that t minus 1 squared times 8 times t minus 11, we can eventually simplify into v of t equals t minus 1 squared times 8t minus 11. We continue on to the next problem. This one be about particle motion. Shiver me particle motion. If you get this one wrong, you'll have to walk the plank. Arrgh. We will have to figure out the value of t when the velocity of the particle is less than 0. Let's blow this problem out of the water. I didn't want to say that. So, v of t on this here number line, we have a negative betwixt the 0 and the 1, and a negative betwixt the 1 and the 11/8. To the right of that mark, we have a positive sign, indicating to me that all greater than 11/8 is positive. Then we see that v of t is equal to 0 when t equals 1 or 11 equals, or the t equals 11/8. We'll roll with it. So the answer is v of t is less than 0 when 0 is less than or equal to t, and 11/8 is greater than t, and t does not equal 1. Arg, now we will find the value of t when the acceleration is 0. Let's just jump into this one and get it over with. A of t equals t minus 1 squared times 8 plus 2 times t minus 1 times 8t minus 11 simplifies to 2 to t minus 1 times 8t minus 1 plus 2 8t minus 11, which simplifies further into t minus 1 times 24t minus 30, which we finally decide equals a of t equals 0 when t equals 1 or 5/4. Since the particle is not moving when t equals 1, a of t equals 0 when t equals 5/4. Therefore, the particle is not moving, and a of t equals 0 when t equals 5/4.